So recall a function f is onto if for all y in the domain, or sorry, in the codomain, so for all possible out, so like R tells you where the outputs are going to be. So for every possible element in the set of where the outputs are going to be, there exists an x such that f of x equals y. So this says that everything in R here gets hit. Everything in the codomain gets hit. For anything in the codomain, there exists something in the domain, so that f of that equals that thing in the codomain. I think that makes sense. Whereas finding, yeah. So, I mean, let's just prove it. So the proof goes like this. Oh, by the way, I'm sorry. We should first ask ourselves, is ln of x one-to-one or onto? And again, I'm going to go to the graph because it's kind of the best visualization we have for ln of x. And if you look at the graph, well, we know kind of if this should go down to negative infinity here. So every value between 0 and negative infinity gets hit right here. We also know that f, from calculus, know that f is an ever-increasing graph. Like this is not an asymptote. This increases forever. It goes to infinity slowly, but it goes to infinity. So this should eventually hit everything. This should eventually hit all y values, 0 to infinity in the positive direction. So this should be onto. It should hit all the real numbers. So now let's prove it. All right, proof. Our proof goes like this. So we want to prove a for all statement here. So we're going to say is let y be any arbitrary / particular element of the domain, sorry, of the codomain, which here is R. And now we want to show for all y and R, we want to show there is some x such that f of x equals y. Let's look at this right here, right? So f of x equals ln of x, right? So what we're trying to show is that for any y, there's some x such that y equals the ln of x. So what does this x have to be? Like, what's x have to be so that we can plug it in ln and get y? That's the question. Let's just solve for x, right? We can solve for x by doing e to the y, e to the both sides like this, and we get that e to the y must equal x. And we can check this. We can check, and we see that, hey, ln of x equals e to the y does in fact equal y. So this means that there is a number, well, as long as x, as long as this is in domain, as long as it's in our domain, then we've just found an element x in our domain, so you can plug into f to get y. And y was arbitrary, meaning we could do this for anyone. So the only thing we have to prove is that e to the y is actually between 0 and infinity. That's actually going to be essential. So I'll say consider x, or I'll say let, we're doing more than considering, we're going to straight up let x equal e to the y. Note, since the exponential e to the y is positive for all inputs, e to the y is going to be in 0 infinity. This is R positive, set of positive numbers for any y. Or maybe I'll put it like this. Notice this is the exponential e, since the exponential function, the exponential function being e raised to something, is positive for all inputs, e to the y must be in here. So y is this particular element of the codomain. And we know that the exponential function is always going to be positive, because you look at the exponential function, right? It looks like this. It's always positive. Since the exponential function is always positive for all inputs, it doesn't matter what y is. For this arbitrary y, either y is still going to be positive. Yeah, the point is e raised anything is positive, so either y is positive. That's all I should say. Anyway, so either y is in 0 infinity, which is the domain. Further, f of x, which equals which equals ln of x, which equals ln of e to the y, is going to equal 1. Therefore, there does exist an x in 0 infinity such that f of x equals y. Hence, the claim is true, f is onto. Yeah, and there we go right there. This proves f, beyond any doubt, that f is onto. For anything you pick in the codomain, I can find you an element in the domain, mainly e raised to that element of the codomain you picked. I can find an element in the domain that you can plug into f to get that element in the codomain that you picked. Yeah.